All right, so here's number 6 from our worksheet, which is this one, completing the square. All right, so number 6 right there. So one advantage of this process, it might sort of look a little weird, but it goes the same way every time, so that's the advantage. So you have x squared minus 10x plus 27 equals x squared minus, so I'm going to look at that x squared minus 10x and say, okay, what's half of negative 10? It's negative 5. Square it, I get 25. All right, so I need that to be plus 25. And then I just say, well, what do I need to make up the 27? I need another 2. And then I can write this part as x minus 5 squared plus 2. All right, so then my integral, 11 over, you could like write this part first, so you don't have to write that again, of x squared minus 10x plus 27 dx is equal to, I'll pull out the 11 every time, I guess that's pretty easy to do, over x minus 5. So in other words, it doesn't matter what number's up here, you're just going to pull it out, so it doesn't matter what it is, over x minus 5 squared plus 2 dx. Now, so the tricky one on this one is we have to take the square root of this number. Remember, this is not a right here, this is a squared. A squared is 2. So we have to take the square root of that, even if it's an irrational number. A is square root of 2. All right, so then we just use that in our formula. So this equals 11 times 1 over square root 2, inverse tangent of x minus 5 over square root 2 plus c. And that's just using our standard formula that we just learned for that. So at least, combine this. If you want 11 root 2 over 2, if you want to simplify that. Do you want to simplify this radical and put radical 2, x minus 5 over 2? You can. I'm not going to. It doesn't really make it any nicer. There you go. There's that. Boom! That's the whole deal. You can do that whole worksheet now. You're only assigned the odds. By the way, I had this question while I was working this out. I was like, well, what if instead of plus something, you had minus something? What if you had 1 over x squared minus a squared? Then what would you do? Instead of 1 over x squared plus a squared, you had 1 over x squared minus a squared. Would this thing work? No, it would not. But what you can do with x squared minus a squared is you can always factor that, because that's a difference of squares. So I thought, what if we did, let's just do an example of that. I thought that's actually a pretty good example. So what if I had a different problem, right? 11 over, and instead of x squared minus 10x plus 27 was x squared minus 10x plus 21, right? Then what would happen? So when I look at my x squared minus 10x, and then I put, let's go ahead and put plus 21 equals. So when I do my x squared minus 10x, and I have to put plus 25, I have to put that. But now, see, it's going to be minus 4. So I have x minus 5 squared minus 4. So what am I going to do with that? Then I have integral of 11 over x minus 5 squared minus 4 dx. Well, what I can do is just factor that as a difference of squares. So the important, basically the conclusion here is that if it's x squared minus a squared, then the denominator factors. And if the denominator factors, you can do parts. But I thought this was an interesting example to finish out, because like if you do this as a difference of squares, it sort of gives you a different way to factor. I guess I'm going to leave the 11 up there. And then, so we can say this is x minus 5 plus 2, x minus 5 minus 2. This is like factoring it as a difference of squares. So I put x minus 5 minus 2 times x minus 5 plus 2, right? Just like if it was x squared minus 4, I would put x minus 2, x plus 2, but it's x minus 5, all right? But then if I simplify those, I get 11 over x minus 7 times x minus 3, which if I think about that, I could have just factored this and get x minus 7, x minus 3. But it's sort of weird that, okay, you could complete the square and factor it that way. I found that interesting. Anyway, how would I do this? I would do partial fractions, so I'd say 11 over x minus 3, x minus 7. See, because it factors, it changes the whole way that I'm going to do it. Is a over x minus 3 plus b over x minus 7. Then I thought this was interesting because all you have over here is a constant. And you have x minus 7 plus b x minus 3. So does just having a constant here throw a monkey wrench in the works of integration by partial fractions? It does not. You usually go 11 equals ax minus 7a plus bx minus 3b. And so then we get, so for the x terms, we have 0. So 0 equals ax plus bx. So 0 equals a plus b. and 11 equals negative 7a minus 3b. All right, so then since a plus b equals 0, it follows that b equals negative a. So we can say that this is 11 equals negative 7a plus 3a, and that's all I'm going to try and squeeze in there. And then we go to the next page. And so we end up with 11 equals negative 4a, negative 11/4 equals a. And since we had from before a equals negative b, right, we had that. So that means that b is equal to positive 11/4. So then our integral of 11 over x squared minus 10x plus 21 dx is equal to the integral of negative 11/4 over x minus 3. And so I could drop this 4 down to the denominator, but I think it actually doesn't help because you're just going to pull it out anyway. So let's just leave it as 11/4, and then have x minus 7 dx. So then, very easily, what you want to be able to do now is look at this and go, oh, I know that is negative 11/4 ln absolute value x minus 3, because the coefficient is 1, so I don't have to do 1 over anything, and then plus 11/4 ln absolute value x minus 7 plus c, and that's how you do that one. All right. So this whole problem that, this example that I created was just because as I was doing this one, I had the question in my mind, what if instead of a plus here, you had to put a minus? And the short answer to that is, if instead of a plus you have to put a minus, then it's definitely going to factor. The factors might be irrational, right? Because if this was 2, I worked it out since before. If this was 2, I would have x minus 5 minus square root 2 and x minus 5 plus square root 2. But I could work with those numbers. They're real numbers, negative 5 minus square root 2, negative 5 plus square root 2, and I could just do the whole equation like that. It would be a terrible mess, but it would be doable. And so there you go. That's how you can do that.